Wait for it. Wait for it. There we go. It is now 2 hours UTC on the 4th of July, 2018. Hey there, everybody. This is Astronomy Daily Live. You can call me Cosmic, and here we are again, gathering together the ever growing, ever slowly growing, but growing circle of friends coming together any anytime you want, right? Anytime. If you want to come in every single day, that's great. If you want to come in, uh, every other day, every week, every month, come on in, right? And tell others that you think might be interested in this kind of content. This is not, I'm not communicating science. I'm not trying to educate in any way. I'm not casting this wide net to see who I can catch. Because I don't think that this is for everybody. Not everybody has, uh, exactly the same interests, right? So, I mean, I mean, there are the most, you folks probably know better than I do what amazingly intense and large communities there are online. It's absolutely mind blowing, right? Just absolutely mind blowing to think about the communities that now exist, and that's what I'm trying to build here is a community of sort of like-minded individuals enough that uh, you know uh, at least what I'm saying and how I'm saying it and all of that uh, seems to connect with those that are here regularly, and I think that's great. And worldwide, I think it's a pretty big crowd, right? I mean, it's a pretty big crowd. So, the number one thing with this kind of thing, which, is essentially, being a YouTuber, right? I think the most important thing is consistency. Um, and if you can throw in, right, if you can throw in high frequency, then those two elements, I well, and the element of time, the element of time, and just some, you know, persistence. My persistence comes from the fact that um, I achieved I achieved my lofty goal on on the first live stream I ever did, and and that is to share a passion for science in general, but particularly with astronomy. So cheers! I've got some coffee tonight in the big thick mug. I'm trying. I'm I'm thinking about I mean, this is just how uh, things seem to operate, and one of the things that many YouTubers do and have available are various pieces of merchandise, right? That followers and viewers can acquire if they so desire. And one of the things that I was trying to think about in terms of making available, right, are these extra thick, heavy. I mean, this is heavy. This almost hurts holding it, right? I don't want to hold it for very long because it's really heavy. But I'm wondering if I can find these kinds of mugs and put the ADL sort of logo that I developed um, uh, on these kinds of mugs, these heavy mugs, not just your regular old mug, right? That when you drop it, it's going to shatter, right? When you drop this, and I've dropped this mug. I've had this mug for about, I want to say about 8 years or so, about 8 years. And in that amount of time, I think I've dropped it 3 times, and it was basically under the same conditions each time. It fell about, well, from the height of a countertop, right, which is what, 32 inches, 30 inches, something like that, onto a vinyl topped floor, um, with just regular old baseboard underneath, right? Wooden baseboard. And every single time that mug that mug bounced. So yeah, I just thought, if I could find these kinds of mugs, right? I mean, these are the mugs that I endorse, right? These big, thick, heavy. I mean, that's a quarter of an inch thick, right? Thick, heavy mugs that you can really hold on to. The only thing that I don't like about this is that it's relatively small, right? I mean, I like big mugs, right? And this is just plastic, right? But that's uh, a quart, I think. I think it's a quarter gallon, right? Um, that's about as small of an amount as I really can tolerate. Um, oh, yeah, I think what you have to do, Atta, is when you go to my profile, you have to ask to join. I'm not exactly sure what it says, but there will be some kind of way on there to ask to join. That sends me a notification that says that you want to join, and then I just have to accept or decline. Um, and I will probably accept. um, and then when I go live, which, as I said, ever I'm definitely for sure going to be doing it 0 hours UTC on Mondays, right? For sure. Okay. But during the week, um, probably if I'm here at 0 hours UTC, I'll fire it up and we'll watch something, right? So today, uh, I screened 2 episodes of a show that was, I think it was produced maybe in the early '80s or so. I mean, he showed us a cell phone, right? I mean, it was this big honking thing, but he showed us a cell phone. He talked about CDs, compact discs. Um, so I'm thinking, and I mean, he's English. So I'm thinking that it's around 80, 83, 84. I'm not exactly sure. But anyway, yeah, it's called The Secret Life of Machines. And what they've done, they produced this series of shows where these two guys, um, sorry, these two guys uh, uh, over the course of maybe a little less than half an hour, like 25 minutes or so, um, uh, get into all the details of a particular sort of household machine, right? So the ones that we watched were the radio and then the telephone, and so yeah, they sort of explain um, the history of how radio communication was even discovered, and then the early things, and they have either copies of or the actual devices that were used in those early experiments. The sparks and the balls and I don't know all that. Um, uh, um, yeah. So but they and then they explain, a very, I mean, not sort of talking down, but trying to find, um, the early examples that have all the elements of like today, right? Or at least what it was back in 1982, 83. Um, uh, So, because the earlier ones are usually simpler, right? Just trying to get this stupid thing to work, right? That's all they're after. Just get it to work, right? So, but yeah. So they explain how they work, and then various applications and all that. And these guys are, I mean, they have a sense of humor that is just, it's really, it's it's very British, very British. It is dry. I mean, it gives me cotton mouth, right? Man, dry humor, terribly dry. Explain us how to push. Okay. Yeah, I think, I mean, if you have an account, the thing that you have to do here, I can show you what I do. It's very simple. It's extremely simple. And I hope that this is answering your question, Bobby. But I'm going to go over to rabb.it, and I'm going to make sure that I'm live here. I think I probably am, but I want to make sure. Yeah, there we are. Okay. So it's all I have. This thing is logging me in, blah, blah, blah. So you go up here to that little uh, arrow pointing down, you click on that, and then you go to my room. And that opens up a viewing room. So you can have an open room. So anybody can come in. I mean, you can still invite, but anybody can come in, or you can set up a private room where it's invite only. So I've been just doing open rooms because I am new at this, and if I'm watching, or if we are watching Cosmos or something else, and somebody happens to come in, while that is going on, then they'll find me, and we'll make a connection, right? So, and that's it, right? So then you host an open room, and then what I've been doing is I've just been going over to YouTube, right? So what you're presented with is like a web browser, right? And you type in the URL that you want to go to, and it goes there. And then you can, I mean, what I've been doing is just playing YouTube videos, but you can go to uh, Netflix, you can go to Amazon, you can do any of these things, right? This rabbit is just broadcasting. That's all it's doing. It's just it's got a big pipe, and you know they're able to push a lot of video through it. That's all. So yeah, it's pretty easy, and any of us who have an account on here can do it. So yeah, I should actually the people who have joined my room, I should probably join yours. So I'll need to figure out how to do that. Anyway, so that's and then when you're done, right? When you're done, you just end the room, and it brings you back to the top page. But right now there are at least according to this, right, there are 30,000 people watching something, right? 76 are watching South Park. 63 are watching Family Guy. Um, 29 are watching Avatar, Bob's Burgers, Buffy the Vampire Slayer. I mean, can't get any better than that. And you can join any of these, right? But you know, the one thing that I have not found, I have not been able to find a way to search for room, like room owners, right? So I mean, you know, searching for myself, right? I type in cosmic, I type in cosmic lattice, I type in um, uh, um, astronomy, I type, you know, just, and I'm not finding. The only thing that this search up here searches for are um, are these video names, right? So if I'm on and I'm running Cosmos, somebody can come in here and type Cosmos up here, right? Which I can do right now, and we'll see. Yeah, see, I mean, there isn't any. There's a group that's called Cosmos, but it looks like some kind of animation thing. So I mean, it's not. Oh, see, there's more results. So there's 4 results. Yeah, see, you know, there isn't anything. These are just groups. So yeah. So bottom line, forget it. Yeah, let's see. How I do you do it here? Yeah, find friends. Find friends. So if I do cosmic here, I'll bet you I'll find myself. Oops, something went wrong. Please try again later. That's ridiculous. All right, let's try that again. Something's not right on their end. Ah, poo. So anyway, I think that's how you would do it, right? You um, you would type it in there. Um, so yeah, I don't know. I don't know. Anyway, those are my followers at this point. All 4 of them. Yeah, Bobby, I think that's it. I think that's it. Yep, yep. and I guess the concept is that you go and rent a movie, and then you bring it home and you invite 20 of your friends over to watch it, and that's exactly what that is. It's exactly what that is. So I don't think it violates any kind of copyright or anything else. Yeah, I'm not seeing any legal problems. Um, Bobby, I guess I'll have to look into that. And okay, yeah. So I'm not quite sure what you mean by sharing video content. Because I mean, I can do that pretty well from right here, right? Um, but I guess, yeah, if I wanted to do it outside of the Hangouts, what you're saying is that there there may be a way, huh? All right, I'll have to look into that. Hmm. Bottom of the page. Bottom of the page. Look at the bottom of the page for the extension. I'm not sure I follow that instruction. Not quite sure what that means. Oh, download the Rabbit extension for Chrome. Patrick wants to join my room. All right, let's get Patrick in here. See, it's all I do is go doink. Cool. Yeah, I didn't mean to. I didn't mean to keep this going, so I'm going to I'm going to end this room because I don't need it. Okay, cool. So to download the Rabbit extension, so I'm just going to add to Chrome. Is that it? It's doing something. It says checking up here. Share on Rabbit has been added to Chrome. Use this extension by clicking on this icon. Share this tab with your friends on Rabbit. Choose a quality setting in options. Huh. All right. I'm gonna have to mess around with that with that, Bobby. Thanks. Um, yeah, interesting, Atta. That yeah, because I guess they're trying to draw a line between a gathering of friends to watch a movie and a you know uh, that same gathering going to a theater, right? So yeah, so yeah, so yeah, I don't know. I mean, you saw the numbers there, and the numbers indicate that there are. there really aren't I mean, there's a lot of video running, right? Because if the most people who are watching is 76, then that you can sort of set an upper limit as to how many videos are running, right? 3402 divided by 76. So yeah, so there's like 400, no more than 400 videos running right now, right? If all the videos that were running had 76 watching, then that would total 30,402 if there are 400 of them. So that's an upper limit, right? It's probably more like half of that. So it's probably double. It's probably 800 to 1,000 videos are running right now. Does that all make sense? So yeah, I just think it's kind of cool and fun, and I'm going to keep doing it. And as I said, um, if I'm here, what if I'm here at 0 hours UTC, then I will I will probably I'll probably pop it on, just because I mean I like to see all those things, all the in search of um, shows are on YouTube. I don't know what the quality is. I don't know anything at all, um, but those are interesting. All of Cosmos is on there, the original. I don't know if the second one is or not. Um, but yeah, there's a lot. There's a lot, and yeah, I probably want to keep it sciency, technology. If it has anything to do with astronomy, yeah, yeah. But I don't want to go too far away from that. All right, well, cool. Hope everybody's doing well wherever you are on this rapidly spinning globe. Yeah, what I can say, Auta, um, uh, about aligning telescopes is everything is sort of a learning curve. And you know what? I don't think that I've ever used auto align. I've on on the system I have a I have some kind of 3-star alignment and some kind of 2-star alignment. And I usually use the 2-star alignment. Um, but I've never used the auto align. I don't remember how that works. Um, have to read the manual to remind myself. Excuse me, how that works. So, but with the 2-star line, it's pretty easy, right? You set the time first. Um, you set the time, uh, and then the date and the time zone, and I forget exactly what else. And what you, what I do is I set a time in the future, right? So I've got the WWV out there, right, using the shortwave. That's unfortunately really the only time I ever use my shortwave radio. It's sad. It's sad. I need to get an antenna on it so I can stick it out my window here because inside there's like no reception at all. It's just all static. but outside, I think it's pretty good. So I need to do that. But anyway, so I use the WWV, and so I know uh, what time it's going to be in the future. Um, uh, um, and so I set the time in the future, so I have time to set everything else. And then at the appointed time, hit the enter button and go to the first star. And so I tell it that I'm going to go to Arcturus, and I say, okay, there it is in the center of the field of view. And then I say, okay, I'm going to go over to Vega, um, and center that, and say, okay, done. And so I tell it what object it is and where it is, and it just needs to do all the rest. And it does it surprisingly well. Tracking, or the pointing, um, well, it can vary. And there are ways. I've experimented a little bit. I need to do more experimentation, but there are ways to sort of fine tune that that sky model, um, because with more data, the model gets better and better and better. And with two stars, you're pretty crude, you're pretty coarse, because look, I'm not going to be able to put that thing exactly in the center of the field of view. That's going to be really close, right? But it's not going to be exactly in the exact center. There's just no way, right? So that induces error right there. So so um, learning how to operate a telescope that can do auto alignment is going to be a learning curve for you as well, and it's probably going to be a frustrating one. Um, you know, I when I got my Celestron, been a couple of years, I guess now. Um, I already know exactly what I'm doing and what I want, and all of that. And so, I could focus on, how do I tell this machine to do what I want it to do? Didn't have to worry about what star is that, right? Because it's like, I know them. um, and where is that star, and is it on the list, and all of that. It's a mess. So yeah, you just have to be really, really patient. As I said, it's and as I also said, you may find a lot of these things that I'm saying are going to be challenging. Maybe you'll find them just, it's like, why does he think this is so hard, right? So everybody has talents that they are completely unaware of. So yeah, yeah. Well, enjoy the curve, because it never really flattens out, right? It never really flattens out, and of course, it never goes back down. Buckminster Fuller, one of his famous lines is that um, you can never learn less; you can only learn more. And I I agree with that. I agree with that. But I put on a little uh, um, like an addendum or a footnote, and that is, um, unless you forget. Yeah. So if you forget, it's almost like you're unlearning. Almost. I mean, if you permanently forget, I guess that would technically be unlearned at that point. But yeah, I think that's I think it's true though that you know, in general, there's no way to learn less. There's just no way to do that. There's only learning more. Um, so yeah, you know, try the auto alignment. Um, I'm I'm thinking, does auto align, does that require GPS? I'm trying to um, figure out um, uh, if there's any way for the telescope to know where it is without. No, I yeah, don't know. Yeah, Atta, Bucky Fuller is one of my huge heroes. He was absolutely amazing, and um, in some ways hundreds of years before his time, and in other ways very few. But in other ways, he was very um, uh, not not naive, but looking at the world through pretty rosy colored glasses, right? The idea of a worldwide power distribution array um, uh, in this world is like, man, that would be such a disaster, right? Because I mean, it's all you have to do is destroy one line and you take out a continent, right? It's like, now if everybody shared and everybody was nice, then of course it would work. Yeah. But you know, there's always going to be creeps, always, always, and we need them as much as we need you and me and everything else, right? But there's always going to be creeps who ruin it, who just completely ruin it for everyone. And I think that's just how it is. So he, you know, he didn't pay any attention to that. That there were you know, there don't have to be a lot of creeps, right? There just has to be a few. Um, but yeah, he, as I said, in many ways, he was 100, 200 years ahead of his time. Um, uh, yeah. I really interesting. If you haven't seen it yet, Atta, and it's on YouTube. Um, it's a lecture that Bucky did over the course of several days, right? I mean, this guy can talk, right? I mean, you probably know this already. This dude can talk, right? 100 million words a second. um, and once he gets going, it's just, I mean, it's like you have to pay attention. He's got a particular vocal style that takes some getting used to as well. Um, uh, uh, but anyway, so check out Everything I Know. It's a series of lectures that he did back in, I don't remember what it said, 1975, 1977, I forget exactly. Um, but it's just a brain dump. It's a Bucky Fuller brain dump. He puts every single thing out there, every single thing that he knows, right? He just does a brain dump, and it's great. It's great. It's really intense. It's 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 really intense, right? I mean, he's a pretty intense dude. He's got a really awful sense of humor too. But no, he's pretty serious and pretty intense, but he's great. Yeah, that would have been cool. That would have been cool. Yeah, he did it. I think he did it in either San Francisco or L.A. I forget exactly. I think it says where the recording is and the date and everything at the beginning of every um, lecture, right? And these lectures go for a couple hours each, right? At least, yeah, I think it's like something like 43 hours or something like that. Just some insane amount, right? Just some insane amount of, and I mean, he's talking very fast, right? So, I mean, you're getting high density English when you watch that one or any of his stuff. Um, and I've got most of his books. One of the ones that I like the most, and I can definitely recommend you all obtain a copy of Nine Chains to the Moon. And this book was written, okay, I got to tell you. So this book was originally written in 1938 and then updated in 1963. Okay? But if you read um, these, it's like, wow, that's happening now. So some things just don't change. Some things just don't change. It's almost been, it's been like 80 years, right? 80 years since he wrote this. And some of the things that he talks about in here, it's like it's still happening. It's still happening. So, um, you know, anyway, check him out. This is a great book. And I hope that's the right way around. I'm going to look at my video here and make sure. Oh, it's really lagging tonight. Yeah. Okay. Well, it's blurry, but at least it's the right way around. So, okay. Cool. Well, check out that book. It's very awesome. Um, he also did a series of interviews on this radio show called New Dimensions. Has anybody ever heard of New Dimensions? I was a pretty intense listener of New Dimensions back in the 90s. Um, but yeah, I I became disinterested. But anyway, back in the 70s, they interviewed Bucky at least a couple of times, and uh, I don't know if it was the first one he was on, but one of the ones he was on, the um, uh, the interviewer was Michael Toms, and Michael Toms asked Bully Bucky some kind of question, right? Just like a really short question, right? I mean, Michael Toms, I mean, he knew who Bucky was, right? Um, so I'm sure he had like a long list of questions, right? Huge list. Um, but he asked his first question, and Bucky spent the next 43 minutes answering it. So that was pretty much the interview. Michael Toms asked one question, and that was pretty much it. So Bucky took us through a history of the world in 43 minutes. It's quite a ride. You should definitely check that out. And yeah, of course, there are fullerenes now, which is sort of a new configuration of carbon. They're also called Bucky balls. Yeah, well, elevator to the moon. I um, I think anything is possible, I guess. But yeah, I don't know. As I said, one of my wishes is to uh, uh, get on a 5 day cruise to the moon and back. So you launch, you spend um, like half a day in orbit, and then you propel yourself to the moon, right? In a figure eight kind of pattern, right? You go around the moon and then back out to Earth, and that would take about 5 days or so, and I think it would be spectacular, absolutely spectacular. I would do that in a second. Yeah. All right. Well, cool. So yeah, as I said, if I'm if I'm available at 0 hours UTC, I will definitely um, start up a room. I guess that's what it's called. Um, so yeah, I will definitely start up a room, and we can probably what I'll do for a while, right, is I'll do like the secret life of machines. I'll do some connections. Have you ever seen Connections? Have you ever heard of Connections with James Burke? There was a number of them too. There's a Connections 2, a Connections 3. So check those out if you haven't. But so Connections, there's Cosmos, um, there's um, I don't know. I don't know. We'll have to look around and find something interesting. Maybe even some sci-fi. Who knows? That's going a little. That's going a little outside of the boundaries, but might be interesting. Um, Yeah, yeah, just ought to, as I say, with everything, just be patient. Um, you'll figure it out. I mean, if you're determined, you'll figure it out. No, no worries. It sort of sounds like you're probably halfway there anyway. So yeah, yeah, yeah. Takes you a while to find it. That's all right. I'll be here. So yeah, I am going to be playing a gig. Um, uh, a little let's see it's what do I want to say here. It's going to be at we're starting at 8 hours UTC. Starting at 8 hours UTC, we're playing at the 4th of July festivities in Tombstone, Arizona. So I guess I don't know if it's the city of Tombstone or if it's some kind of organization or something. It's putting on some music, and my partner is a native flute player, and I play a keyboard accompaniment with him, and yeah, it's a lot of fun, and it's going to be, as I said, it's going to be at 8. No, not 8 hours. What am I saying? 13 plus 7, 20 hours. That's right. Yeah. Sorry about that. It's going to be at 20 hours UTC. 20 hours UTC. Yeah. Is Mountain Standard Time is 7 hours behind that, so that's 13 hours. That's 1 p.m. So yeah. Yeah, I can do that. I can do that. Can I do that? How easily can I do that? Oh, I know. I can do it like this. View profile. Oh, I'm already there. So I'm going to copy that and I'm going to put it in the chat. You should, Atta, you should just be able to click on that link and possibly a new window will pop up or a new tab. Yeah, that's correct. So see if that gives you any satisfaction at all. All right, so let's I was going through some papers, and so I'm gonna just. It's amazing. It's already 2:52. It's amazing. Time flies when you're having fun, and time is sure going by fast. So what does that mean? Ha. So I went over to progress in physics as well. Now, progress in physics is pretty way out there stuff, right? Really, really, you know, pretty intensely crazy, right? Crazy in a good way, right? I just like to come over here and see how the latest issue is filling up. See, they open it for submissions, so when they get something that they want, um, uh, they publish it, right? And it's a PDF file here. And but yeah, these I have no idea. Elimination of anomalies reported for B to S / and B to C / V something. Semi-leptonic decay ratios. When the lepton families represent discrete symmetry binary subgroups 2T, 2O, 2I of SU of 2. It's, I have no idea what they're talking about. I mean, that is just, to me, that's a random sequence of words. And a lot of these are like that, right? They are way out there. But, all of these people are really into what they're doing, right? I mean, you've got to be really into what you're doing to, write a paper like that. And a lot of these papers are done by, I guess you'd call them amateurs. Now, that's not totally true. I mean, not all of them are, but some of them are. And, but regardless, right? Um, this is like, some pretty far out stuff. and I just admire them for, you know, putting forth this kind of effort. Um, it's just, you know, I can't really imagine doing this kind of work. Um, but yeah, okay, so I don't really see anything too new here. And the things that I do see new, I don't understand. I have uh, no concept of really what they're talking about. Um, so so that's that. Let's go back to maybe what you call the more conventional astronomy. These are the ones for Wednesday, July 4th. Yeah, I mean, I'm hopeful that we'll get more and more and more uh, um, uh, what's that called? When two or three things mix, right? And I mean that's starting, right? That's starting, but um, there's very 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 little communication between um, even specialties in the same field. So somehow we have to open those communication uh, lines a little bit more and get this cross pollination stuff going. Um, because I mean, I've seen it in some of my um, some other work that I've been doing, where you know uh, I'm looking at almost completely different kind of data, but it's sort of representing the same kinds of things that I see over um, over with astronomical data. And so I know how to understand and interpret and read the astronomical data, so it's easy to translate over to this other stuff. So yeah. Anyway, let's see if there's anything interesting here. Just rambling and rambling and rambling tonight. So the Gala survey and Gaia data release 2, non-existence of 5 sparse high latitude open clusters. So sparse open clusters can be found at high galactic latitude. So, galactic latitude and galactic longitude are just it's just a different coordinate system, right? In galactic coordinates, a latitude and longitude of 0 would be the center of the galaxy. And then as you um, as you move along the disk of the galaxy, you're changing longitude, and as you go perpendicular to that disk, you're moving in latitude. So there is a north galactic pole, and there's a south galactic pole, and uh, those aren't like real. They're just points in the sky that indicate a direction, right? That's all it is. It's just a perspective. It's a different kind of perspective. Um, anyway, so these are at high galactic latitudes, which means they're way above or way below the plane of the galaxy, um, where loosely populated clusters are more easily detected against the lower stellar background, right? Because I mean, uh, the the number of stars in the disk of the galaxy is absolutely huge compared to, you know, these outliers. These outliers. Hey, I think you got in. Atta, I think you got in. You did. There you go. I don't know. I don't know how or why it's making that. I can hear a sound. Anyway, so yeah, we're in. We're in. Yay. Yay. So, because most star formation takes place in the thin disk, the observed population of clusters far from the galactic plane is hard to explain. So we combined spectral parameters from the Gala survey with the Gaia Data Release 2 catalog to study the dynamics and chemistry of 5 old, sparse, high latitude clusters in more detail. We find that 4 of them, all NGC objects, originally classified in 1888, are not clusters, but are instead chance projections in the sky. Can you believe that? Wow. Holy moly. So 4 NGC objects are not open clusters. That is very cool. That is very, very cool. Yeah, that's awesome. So, member stars quoted in the literature for these 4 clusters are unrelated in our multi-dimensional physical parameter space. The published cluster properties are therefore irrelevant, right? Because, yeah, I mean, what you do with clusters, right, is um, you create color diagrams or color magnitude diagrams. Um, what are what's the a Hertzsprung-Russell diagram? So, and you can, if you make the assumption, right, that all these stars that you're seeing are part of this cluster, right, members of this cluster, well, there are certain assumptions that are made about um, membership of a cluster. And one of the assumptions is that they were all formed about the same time. So all the stars in the cluster are about the same age, right? And so then what you can do based on that, making that assumption, right? You can look at a Hertzsprung-Russell diagram and see what the relationships are, and get a sense of the population, um, and then that allows you to get a sense of how the stars are evolving, how old they might be, all kinds of things. It's all based on models, but they're pretty good models, I think. Excuse me. So, but they're finding that these 4 so-called clusters, those stars are not related to one another. Therefore, they did not form at the same time, and therefore any inference that they make by looking at the Hertzsprung-Russell diagram of these clusters, they're going to come to the wrong conclusions, and probably have until now, right? So yeah, you got to scrape those off the list. So we confirm the existence of morphologically similar NGC 1901, for which we provide a probabilistic membership analysis. An overdensity in 3 spatial dimensions proves to be enough to reliably detect sparse clusters. But the whole six-dimensional space um, must be used to identify members with high confidence. I noticed that Patrick is wanting to also come into the rabbit room. I think I'm calling it the lettuce bin, if I remember right. Yeah, cool. All right, you guys are coming into who knows what over there. So let's see. We didn't even get to look at the actual paper. That is cool enough. Just knowing that it's like, look, you know, we can now with this data that we have, we can um, cross objects off the list, right? That's pretty interesting. Pretty cool. Photon number conservation in the large scale 21 centimeter power spectrum of semi numerical models of reionization. Wow, that's a mouthful. Yeah, I'm gonna do friend requests as well. I apologize, but I mean I always forget to do that kind of thing. Try, and I sometimes don't remember. Self-enrichment in globular clusters, the extreme helium-rich population of NGC 2808. After several decades after the discovery of the first multiple populations in galactic globular clusters, the debate on their formation is still extremely current, and NGC 2808 remains one of the best benchmarks to test any scenario for their origin and evolution. Well, 2808, let's see if HST has looked at you. Yeah, anybody can do it. Search for everything. Oh, look at that. It's there. Wow, only observed in 19. Oh, no, there we go, 2013. So let's see if these images are available. Oh, it is. Cool, there it is. NGC 2808. Far out. That's a pretty globular. Look at all them stars. Holy moly. So pretty cool. Now, I don't think I'll drag you into an imaging session, but um, there are 3 wavelengths there. Is this all the same proposal? Let's look and see what they were doing. This is back in 2013. What else we got? 2011, 2010, 2006, 2005, 4, 2001, 2000, 99, 98, 95. Wow. Pick 3. Wow, that's pretty awesome. Let's take a look at one more. That's awesome. That's a nice glob. Anyway, it's got some problems. NGC 2808 remains one of the best uh, benchmarks to test any scenario for their origin and evolution. In this work, we focus on the chemical composition of stars belonging to the extreme helium-rich population populated by stars with the most extreme abundance of magnesium, aluminum, sodium, oxygen, and silicon. We check whether the most recent measures are consistent with the AGB yields of stars. AGB is the asymptotic giant branch. It's a portion of the um, Hertzsprung-Russell diagram that usually pretty massive stars move through pretty quickly. So it's kind of cool to see them in that phase because they're changing. Yeah. So these stars evolve on timescales on the order of 40 to 60 million years and eject matter strongly enriched in helium, uh, owing to a deep penetration on the surface convective zone down to regions touched by CNO, that is carbon, nitrogen, oxygen nucleosynthesis. So the fusion of carbon, nitrogen, and oxygen into heavier elements occurring after the core helium burning phase. Since the big unknown of the asymptotic giant branch phase of massive stars is the mass loss, we, we propose a new approach that takes into account the effects of the radiation pressure on dust particles. We show that this more realistic description is able to reproduce the observed abundances of magnesium, aluminum, sodium, and silicon in these extreme stars. The large spread in the oxygen abundances is explained by invoking deep mixing during the RGB phase. That's the uh, something giant branch. Um, I don't know what RGB is. It will be possible to check this work hypothesis as soon as the oxygen measurements of the main sequence stars of NGC 2808 will be available. So somebody has to stick a spectrometer on a scope and point it over there and go from there. Where is this thing? Oh, it's way in the south. See the declination here, negative 64. So yeah, it's like way south of like Orion, right? Way to the south, way to the south. So yeah, us up here in the north, we will never see that. But of course, the HST can see pretty much everything. So let's see what these folks were looking at here. So this is a proposal to use with PIC uh, or the Wide Field Camera 3 for striking new advances in the populations of globular clusters. Now that recent work, much of it by our own group, has shattered the 50-year-old belief that each globular cluster represents a single event of star birth with a single chemical composition, we propose to exploit the superb ultraviolet throughput of the Wide Field Camera 3 to split main sequences with an unprecedented fineness and follow them in all evolutionary sequences up to the horizontal branch in a quest to finally solve the long sought second parameter. From our vantage point, in the midst of these developments, we feel that the present day situation merits a concentration of efforts on HST ultraviolet resources that in a few years will not be available anymore. This was in 2013, right? Uh, we therefore we are therefore proposing to observe two classical second parameter globular cluster couples. NGC 28 or 288, NGC 362, and M3, M13, and 3 clusters with extreme horizontal branch extensions. NGC 2808, there it is, M80 and M15. So they were looking at a lot of globular clusters. The main sequence study will cast particular light on the question of helium enrichment, whereas the clear separation of the more advanced evolutionary sequences, and I don't know what all those mean, will allow us to identify the evolutionary paths of each individual subpopulation. In this way, we shall gather critical information capable of shedding fresh light on the sequence of events that have been responsible for the subsequent formation of the various subpopulations. So they're seeing subpopulations in globular clusters. And so they're saying, well, that means they didn't all form at the same time. Or that, the sequences of evolution are different. So yeah, interesting stuff. Nice pictures. Let's look at this 275 one here. It's a nice long exposure too, 1970 seconds. Yeah, that's a couple stars. That definitely is a couple of stars. Pretty nice. Yeah, pretty nice. Gotta say. That's a couple. You look at it long enough, you start seeing patterns. Like, look at this line of stars here, this line of stars here, and it's sort of, there's not a lot of stars here. It's interesting structures, right? And problem is that, we're seeing a two-dimensional representation of a three-dimensional object, right? This is a sphere of stars, right? So some of these stars, a lot of the stars that you're seeing towards the center, right, are on our side, and we're not seeing a lot of stars sort of through it on the other side. I mean, we are, but we're seeing through this. So this is like a sphere that gets more and more dense as you move in, right? Yeah, I think it's great how our brains do that. We are hardwired to see patterns, even if there is no pattern at all. We will see something, right? Which is fine. You just have to accept the fact that it's not actually there, right? Our brains are amazing. All right. Well, look, I think I'm going to get out of here for this live stream. Looks like I'm already over. Yeah, well, as I said, time flies when you're having fun, and time is sure flying. Fast. All right, I'm going to get out of here. Take care, everybody. I will see you on the spin tomorrow, a little less than 23 hours from now. So, subscribe if you haven't already. Hit the thumbs up if you haven't already. Share this around. We're looking for our core group. I'm not necessarily casting nets, right? I mean, casting nets is okay, but I think I'm looking more just for the core. And I keep adjusting this terrible camera. No, I still haven't ordered it yet. I need to order it. I will do that shortly. Just a matter of remembering to do it. All right. Take care, everybody. I will see you on the spin after the gig. I'll talk about the gig a little bit, probably. All right. Take care, everybody. Bye.